It's boredom time with Naoki-san, and today I thought we'd look at Crisis Zone, but I'm not going to give you anything. Well, what I thought I'd do today is just basically tell you what I know about this board, as of or was it August 15th, and I just go through all the different parts so you know what stuff is, how it works, and how you could improvise, and if you this can cover like getting it to run outside of a cab, getting it to run if you have broken parts, or just general things. And this will also apply to Time Crisis 2, and also it will apply to pretty much any System 23 game. I would be tempted to say System 22, which is Time Crisis, but it's not exactly the same. So yeah, so what I thought we'd first get started with is the main case, or the actual main boards. This is the System 23. This is actually the System Super 23 case, although the main board is System Super 23 Evo 2, which is a mouthful to say, especially when it's late at night. This is JVS 15 kHz spec, so basically you got your JSTVL 6-pin connector, which is your 3 and 5 volt pins, ground, and that's standard. You can find that on the Naomi, you can find it on the Triforce, you can find it on the Chihiro. Pretty much most JVS systems have that, although most JVS systems either have this or they have the JST 8-pin, which is just the same except for it's got 12 volt on the end of it. This is your 6-pin connector. This is actually your ring network connector for connecting various games. So on Time Crisis 2 you'd have this cable, which is essentially a crossover cable going to your other System 23, which could talk to that. This is your I/O connection. This basically contains a JVS USB, not USB connector. It contains video out and power, so you got 5 volt out of this, you got your JVS connectors, and you've got video out. This is your D-sub 15 kHz composite sync output, so it's compatible with Jammer if you really want. Well, it's not actually, yeah, it is pretty much compatible with Jammer, although you will need a video amplifier if you want to use this on a Jammer cab, because these operate at 0.7 volts, I think it is, and Jammer cabs require like 1 volt or more to operate correctly, or otherwise it's a very dark picture. This is your sound out connector. What's interesting about this board is that it actually has left, right, and subwoofer, or left, right, and third channel, because the actual mixing of all the stuff is done through this board. The amplifier PCB just literally amplifies that. And this is your front panel. This is pretty much used on all, I'm tempted to say all System 23 games, but some might be different, but for the general most part this is what you'll find. So you've got power, network, I/O, video, sound, and that's really all you need to know about this board. There is inside this board there are a set of dip switches. This is a 8 long random can falling outside. There's a set of 8 dip switches in a line, 1, 2, 3, 4, 5, 6, 7, 8, and yeah, I think it's I think the only times you'll ever need to know the dip switches is 1, 2, and 3. I think one skips the service mode, not service mode, skips the system startup test mode. So if your system boots but it has an error, but you don't, it's not an error that really causes any effect, but it's really, like say is a IRQ error or something like that. You have to press a button on the cab or one of the service switches to actually get it to do anything. But if you flick that switch, you'll just wait for the I/O PCB to initialize, and then it will just go straight into game. Which is not always the best idea to do, but if the game works and you're happy with it, by all means you can deflect that and work. It's either one is skip test mode or 2 is. The other one you'll be using is the actual test mode switch. Now Namco games, and this applies for all of them I pretty much think, they on the service panel they have the test service, and you have to test switches, service switches, and then the coin counters and all that guff. What's different about Namco is that they actually use a switch. So whereas on most games get most games and games cabinet you'll find two buttons, one to test, one to service. The other one is on Namco games you'll find a switch, and especially on the gun games you'll find a what is it? A DP it's double throw. I think it's on off on. No, on yeah, on off on switch. So, but it's momentary. It's a really weird switch. So, no, it's yeah, double throw single pole on off on momentary switch, and that's basically it's like a toggle switch, but it usually rests in the middle on, and then it's got two positions for up and down. That's usually how they deal with their test menus on the gun games. On well, except for Time Crisis, but that's different. On the on Time Crisis 2 and Time Crisis, not Time Crisis, Crisis Zone, it's a momentary switch. And yeah, so a couple of things, but on if you don't have a setup that facilitates that, I mean, but one, get one. Two, if you want to get into the test mode, I think it's dip switch, either one or two. I can't remember at the minute, because I remember this board didn't work, and I actually don't have this board at the minute. It's away being repaired. So it's one or two. You flick the one of them on, and it'll go into the test mode and stay on there until the dip switch is flicked back down. I wouldn't recommend actually touching the PCB because these are fragile beasts and they are a pain to fix. But if you need to, that's how you do it. The other dip switches, there's actually a option to freeze the game, but I don't think Crisis Zone does that. In fact, no, I don't think Time Crisis does that, but I don't think I don't know about Crisis Zone. Pretty much that switch is relevant, and all the rest they're not used. So I think though if you flick dip switch 6 or 7, it actually just crashes the game. So just don't do that. Anyway, I'm sorry about that. So yeah, that's really all you need to know about the inside of this board, because everything else is, I mean, there's status LEDs, but for the most part you don't need that unless you're diagnosing. But again, I can't help you with that. So moving on. There's a compartment down here on most System 23 games, like the Jammer ones. This is where your I/O board would be. Basically, there's little screw posts in this on the underside of the mounting bracket for the PCB. That is where your I/O PCB would go, and then you'd have your power connector for the I/O PCB there. The I/O PCB connector, it looks like the Sega connectors, actually, the Sega JVS I/O connectors, which are JST. What are they? They're not VL. I think they're NH or something like that. No, not NH. I can't remember, but I don't know if they're the same. So, but the big connector, you see the big back connector. That is your that's the majority of your cabinet inputs. But since most Namco games aren't standard joystick-based games, don't expect to be making a JAMA adapter for it. I should point out, I'm not going to go through all the pinouts. I mean, power connector was easy enough, but I'm just giving you a reference of what each part does and how roughly it works, so that you can get a general understanding. I mean, if you need to know more information, you can always ask, but there's no guarantee I can answer it. That connector I've never seen, so don't ask me about that. All this wiring, by the way, is just pretty much the wiring from Crisis Zone's cab. We all know this, but it's just storing it in there because I've got no I/O board that goes in there, so why not store it in there? Oh, my hand's getting a cramp. So, on the side, and this is the last thing pretty much to know about this PCB, this is a 120mm mains voltage fan. So, where you got your normal PC fans, which are like 12 volt or 5 volt occasionally. This is a 120 volt fan. This is usually 120 volt, although you can get 240 volts. It's very important to check the actual fan rating. You'll be able to see in there, it says the rating. It's covered by the grill a bit. It says 230 VAC, meaning this is a thing where you can put 230 volts AC to it and it'll work fine. You don't want to connect 230 volts to, AC to a 120 volt fan. That will cause it to die, quite catastrophically, I might add. Putting 120 volts onto a 240 volt fan, it will work but at like half the speed, so I just wouldn't recommend it. I mean, just get the right. If your fan is different to what your cab voltage or your actual your mainland voltage is, just get a different one. Get one that's rated for your country. Other options are to just literally take this off and put a PC fan on there. Now, yes, it's a bit hacky, and to be honest with you, the airflow is going to be less, but it will work. And actually, I've been talking to the guy repairing this board, and because I got that, and it had a 120 volt fan, but the fan was failed. It actually didn't spin very well. I think it's sort of. I pretty much believe that overheating caused the PCB to die. So yeah, this is an essential piece to this cabinet, or this board, sorry. So have this, even if it's just a cheapo PC fan, as long as it's got some good airflow coming out of it, that'll work fine. Also, you want the airflow going out of the board. You want the hot air being sucked out, not cold air being blown in. I don't think it really makes a difference, but just personal preference. Anyway, that's pretty much the main of the PCB. So, like I say, video, input, power, network, sound. This sound PCB, you shouldn't have to worry. You don't need the amp PCB so much. There is a AV sense which basically turns the amplifier on or off depending on what the board state is, but you don't need to know that really too much. But yeah, that's pretty much that. Like I say, this is standard. This is standard. Nothing different. Like I say, this is composite 15 kilohertz RGB. So yeah, if you can't just plug a VGA monitor on it. It won't work unless your monitor is very special. So yes. Anyway, let's go on to the next piece, shall we? I should also point out I am a bit not throaty, a bit low pitched because I'm trying to be quiet and it's late at night, so a bit tired. You understand, don't you? Don't you? Anyway, onto the I/O board. Now, this I/O board is very unique. It's only used on Time Crisis and Time Crisis. It's only used on Crisis Zone and Time Crisis 3. Honestly, the names are too similar. That's my excuse. This is called the Raise PCB, and this does a very interesting way of knowing where the gun's been pointed. This is only used on Crisis Zone and Time Crisis, only used on the camera models. The way you can tell between the different models of Time Crisis 3, because Time Crisis 3 came in two versions. One with the Raise PCB and one with the standard light gun model. And what's good about Time Crisis 3 is no matter which version you have, whatever System 23, if you've got both I/O boards for System 23, you're set. You don't need to worry, because you can literally use the exact same board on Time Crisis 3 as you can from Time Crisis 2 or Time Crisis Zone. So literally, if you have the gun set up for an example Crisis Zone, you can use it fine. If you have the gun set up for Time Crisis 2, you can use that fine. You just, as long as you've got one of the two I/Os, and the other I/O is a 1V8, sorry, I'm trying to remember these at night, it's not easy. V185 PCB, and you'll know it's that because A, it doesn't look nearly as complex. It has a couple of connectors here, it's about that big, has a S-video connector I've usually noticed about there. And yeah, that the S-video connector is pretty much what you're going to know. Now, I have to say, this will determine what gun you need to buy, and it will also determine what version your cab is going to run. Now, there's two versions of Crisis Zone. There's the standard and there's the deluxe. The deluxe is massive. It's huge, and for some reason the guns in that are different. I don't know why. I'm just going with what I know. The guns are different. Also, these boards are different. You will get a different Raise PCB for what, depending on cab. This is the JVS Raise OA and JVS IO. This is essentially this is the Deluxe Cab IO board, and you will only find this in the Deluxe cabs. I don't know if Time Crisis 3 matters between the two. I mean, I don't know. I mean, I think functionally they're the same, but they work a bit differently. But anyway, I digress. The So like I say, there's two different boards. This is the deluxe version. I'll take a closer look. If you have an IO board like this, you've got the deluxe version. Now, well, if you if you're gonna have if you have gun issues, then you want to stay watching, because I'll explain why that's the case. Yes, the other version of this board, it's a bit more compact. It's like about that size. You've got your SH4 CPU. You've got an Altera FPGA chip, and you've got all the same connectors. It's in a different package, and you can find, if you could do a Google search of Namco JVS Raise IO PCB, or just Namco JVS, or Raise PCB, you'll find the different versions. You can actually find me showing off this one. You can find another one. Now, the way this board is very interesting. The way this board works is very interesting. I really need to wake you up before I do these videos. In fact, no, I'll go on to that in a minute, how it works. Here we've got our power connector. I've already gone through the pinouts of these in my former videos, and plus I think they're pretty much self-explanatory. But you've got your 5V and 12V input. On the actual standard harness, the 5V comes directly from the main PCB, because remember how I had said the IO connector had the 5V? Goes straight into this. The 12V comes from the actual cab's main 12V feed. This connector is not used, that connector is not used. This is your camera input, which we'll go on to in a minute. This is your service door and coin door input. This is basically like your test switch, service switch, up, down, left, right, not up, down, left, right, up, down, select switches with the test mode. This is your gun trigger input. No, sorry, not that. That's your, that's the coin door, and basically coin in and all of that stuff. And also has 12V output for the coin door as well. It's very interesting. It's like daisy chained power supplies. This is your cabinet select. Now, if you've got two of these cabinets together, I do believe you can cut the wire, and because there's like a bridge, you can cut the wire, and it will tell the board. It will basically set a different sync rate, because obviously if you've got someone else's gun pointing on your screen, you don't want the game to go, what? Because then it won't be able to track. So you can, I don't know if this is true, but I think you can cut the cable to change the thing. But generally that's that. And this is also your foot pedal input. I'm not going to cover the pinouts like I said, but your foot pedal attaches to this, and this is also, like I said, this is your sync thing. This is your gun input connector. This provides no, it doesn't. This essentially is your switches input from your gun, and this is also your trigger input. This deals with 4 signals, and it deals with ground. Basically, it will deal with the trigger signal. It'll deal with the solenoid is working signal, which means if the solenoid is working, the gun will tell this board, the solenoid works, and then this board will say, okay, then I'll use E. If it doesn't, it'll tell the game, and the game will then say, your motor is broken. Not a big killer, because you can still play Time Crisis Zone with without the motor, but it will say if you don't have it set, you'll have to go into the test menu and change that, because you can play it without it, but it's not as fun. That's basically what that signal does. You've got your LED on, which is basically the IO board telling the gun to turn on the LED, because there's an LED in the gun, which we'll come on to in a minute. This tells the board motor on, which is basically fire the motor, which turns on the motor, turn on the cam mech. We'll come on to that in a minute. And ground, pretty much that. I think I'm missing a pin or two. I'm trying to think of what it is, but it deludes me at the minute. No, I've forgotten. Essentially that's your gun input connector anyway. And that's your JVS output, or input output for the system. This contains your sense, data minus, data plus, ground. Not used. I've gone on to previous videos about these LEDs. I can't remember the which ones are which, because I've not filed this board on in ages. a set of 4 just go across left and right like a Knight Rider logo. This is just essentially to say the board's not is still working, it's not locked up. And these LEDs are status LEDs. They say what the board's doing. So one will say whether the board's receiving JVS I/O data, one will say if it's receiving camera data. I think the other two may be related to the gun, but again, don't have crisis zone to test. God, I'm awful today. These dip switches aren't used, but on mine they're set all to off. Yeah, so now we should go on to how this board actually works. And it's interesting because you notice it's got an SH4, which is the same processor as the Naomi, and you know, it's just essentially an embedded processor. But what this board does is the camera is essentially an NTSC camera, and it takes its input from here, and the gun itself has an LED in it, which when you pull the trigger and the game is working, the game will tell the LED to turn on, and that will shine a light at a particular point on the screen. So say point A, so say your screen is X big, but you shoot at point A. What will happen is the infrared LED will light, and because humans can't see infrared, you won't see anything. But the camera will be able to see exactly where you've pointed, and it goes into a really interesting process, because this is why you really need to calibrate the gun before you play the game, because if you even move that camera slightly out of position, you'll mess up the entire readings. But when you shine that light onto the screen, the camera sends the image of literally the whole screen plus wherever the light is, and then this SH4, and I think in combination with this Xilinx Spartan FPGA, it then basically does processing to figure out where you shot on the screen and where exactly it is in relative to what the what the game is showing. So say the game is showing you shot, and say the game is having like 3 enemies and you shot at the rightmost enemy. The game, it would basically, it's complex. When you set where the screen is, you literally set where the camera should be able to see on the screen, and then it will basically use those points to measure out where you're shooting on the screen. Like most normal light games, but it does it in a different way, that it actually compiles where you shot on the actual video. Because in contrast to a traditional light gun game where when you pull the trigger the screen refreshes, but it takes a while before it gets to the point where you shot at, and when you shot wherever you shot the screen, when you get to that point, it will say to the gun, oh, I've got a signal, and then the game will then determine how long it took from the last refresh rate, basically going from bottom to the top, to how long it took before your gun registered you shot, where you'd shot. That's how it basically works it out. Again, you need to set it up per CRT game, and it's kind of a bit iffy. I mean, the same thing applies here, but it's just using direct video, so it's literally seeing where you're shooting. But this thing has to decode NTSC video, find out where you shot, and then convert that into a relative analog data stream for the game. It's very complex. I mean, I've not even given a good description, I bet you. So yeah, really interesting that it converts and calculates all this in what is it? A blink, a split second. So you literally pull the gun trigger, and it's already found out where you're shooting. Pardon me. Over here you've just got a couple of power regulators. One is 2.5 and one is 1 volt, I believe. Yeah, I think that's the case. No, one is 2.5 and one's 2. I don't remember. Anyway, that's the I/O board. Very complex piece, and like I said, there's 2 versions. There's this one, this is the deluxe version. The standard version functionally is identical, but it really makes a difference to what parts you buy. To the game it doesn't matter, to the parts, yes it does. Gun. Oh, how many times have I replaced that transistor? This is a running joke to how many times I've blown up the transistor in this gun by wiring this up backwards. Yeah, first and foremost, This connector here, which is your yellow, green and purple, may differ depending on what country you live in and what time your cabinet was made. This is your 24 volt input and your 5 volt input for the LED, because although the LED is 3 volt, no, it's actually 1 volt. No, it's not. It's weird. This gun steps down the 5 volt it gets in here to 3 volt, and then it steps it down to 1 volt. Namco, you work in mysterious ways. This control. Oh yeah. This is 5 volt input, but it doesn't have a ground. The only ground is for the 24 volt. So you literally connect the 24 volt directly up to this, and then the 5 volt, one of the 5 volt lines up to this. Doesn't need to be much. It's about a couple of milliamps, but even so. This is common ground. This is earth. Sorry, not ground. Earth, ground, same thing. This is your gun. Trigger and sensor inputs. This basically goes from your this goes to your JVS Raise PCB on the gun input connector, and then this is another ground. Earth. Strange. I'm not going to open this gun. Too late to. Well, it's too late, and I really cannot be bothered to open it. Inside this part here, this is where your 24 volt motor is. This is made on a camshaft assembly. Basically, the motor is connected to a gearbox, which reduces it down to such a voltage, not such a voltage, reduces to such a ratio. But after the gearbox, it goes straight into a cam, which is, if you don't know what cam is, it's a cylinder of plastic in this case, and it has a groove that's at an angle. So whereas just imagine this is the edge of the the cam, whereas you've got the actual cylinder is straight, there's a notch which is at an angle, and then the recoil mechanism works by every time this cam rotates, it reaches the end at the highest point and then flicks back. There's a spring and a slide. So similar to how the time crisis guns work. See, now I'm confusing time crisis for crisis zone. Similar to how the time crisis gun works, when the game wants to make a recoil, it pulses a solenoid, and a solenoid pulls a slide back, and literally pulls the plastic slide with it, pulls the slide back, and then lets go of it. This is a similar thing, but it pushes it. So the motor uses a camshaft to push it forward, and then once the camshaft reaches the end of its path, the spring will then push it back, and that's what gets you your reciprocating motion. So it just literally goes forward and back all the time, very fast. If the motor isn't working, it's not the I/O board that determines if it works or not, because the actual gun sensor board inside will determine that. The actual board itself is very simplistic. I've already put in loads of videos about it before. By now you should know that there's two transistors. One controls turning the LED on, and one controls turning the motor on. The actual way this board works is when the game, like I say, when it wants to know where you're pointing, it turns on an LED. So down the scope is, behind that lens is a infrared LED, and when you turn that on, you can see it with the naked eye, but it's very dim, very dim. And it just literally tells the transistor to turn on the LED, and then it does that. So essentially the I/O board is doing all the work of the actual gun, but the gun is what controls when stuff turns on, when stuff doesn't. Also has a trigger, but anyway. Stupid. Oh, thank you, PC, for shutting up. PC's making an annoying noise. It's making an annoying noise, and it's really driving me up the wall. Anyway, sorry for wasting your time. Like I say, these guns will not work with each other's I/O board. This is the deluxe gun. The standard gun, it looks identical. I know, that's really annoying. How do you know which gun you've got? Only option is to open up all the screws. So you got one there, 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 one there. Actually lift it off, and then there's a board right about here. Lift it off, and it'll say gun DX or gun SD. If you got this, it says DX, Deluxe. If it has SD, standard. I think the difference is the placement of the LED and maybe a couple of components, but not a huge difference. Just enough to make this gun not compatible. Again, why? Presumably because of the way the cab was designed, and they realised the standard gun didn't work on the Deluxe, or vice versa. Anyway, so the gun is very simplistic, very easy to repair, and if your 24-volt motor goes, well, I'll be finding a replacement, or see if I can find a replacement, just if we can. So yeah, but you can literally use off-the-shelf components, and if you need any help, if you say something's blown up on your board, you just literally PM me, not PM, or well, you could PM me, just give me a comment, say where exactly on the board something's blown up, and I'll tell you what the values are, or what the things you need. Word of note, the transistors are both PNP, meaning when you ground them, they turn on. I've figured out that the hard way. Anyway, so gun in a nutshell. And the final part of this very long video, probably the longest video I've made and the most boring video. This is the camera. This you can, if you don't have this, don't worry about it. There's a nice replacement for this. This is a later model version of the camera. I got this part. I actually asked specifically to get this because although I could replace it, I didn't know at the time, and secondly, well, it looks nice, and plus it means I can mount it to look at the screen. This camera literally looks at the screen. If you have to see the entire, it has to see the entire screen to work properly. And inside it, I've already gone into details of what it is. This is an NTSC 4x3 black and white composite video, camera, CCD camera, and any CCD camera that's NTSC, that's 4x3, that's composite, will work exactly fine. Obviously mounting it may be a bit of an issue, but I'm sure we can get around that. Because really, that filter, that black filter, is just literally an infrared filter, so although you can still see through it, through the camera, it gives a nice clear indication of where the actual infrared light is on the actual screen. Anyway, this part, like I say, is entirely replaceable. Just get any camera I don't know if it has to be composite black and white, or it has to be composite color. As long as it's NTSC and as long as it's 4x3, you should be fine. S-Video, obviously, it might work if you get a composite adapter, but I wouldn't guarantee that. The actual plug is very simple: 12-volt in, video out, 2 grounds. That's it. This camera is this actual plate. Usually, on the original versions, I had a slot cut out there. That behind there was a proximity detector. I think it was just like an IR emitter and a receiver. So if you block this camera off, the sensor would trip, and the I/O board would then register that, and then the board would say, can you remove the object, because you can't play the game otherwise. This is probably why you don't see this system more often, this camera system. Probably that, and the fact that they made better LED tracking systems. Anyway, but yeah, if you don't have this, obviously I don't have it, so it's not a big issue, and the manual even states you can run it without the sensor connected, but if you don't, you're not going to know when the sensor's covered. So if you cover the camera up, obviously it's not going to see a darn thing. But yeah, very simple replacement, off the shelf component. As long as on your TV it's black and white and it's NTSC, it should work fine on Crisis Zone. That's the theory, not tested. I mentioned that, sorry, going back to the Raise PCB, this is very brief. I mentioned that these PCBs are only used on Time Crisis and Crisis Zone. That's true, but Vampire Knight used a revision of this, which is the Raise PCB 2, I think, which does the exact same thing, but it uses, I think, the one board controls 2 guns. Now, obviously, when you can control the LEDs and because it only needs one camera. When you can control the LEDs, you can have one on, one off, one on, one off. You know, so you can flicker between the two to figure out where the guns are actually pointing. I don't know if this gun board is compatible with Vampire Knights, but you know, it might be. It might work quite nicely. You know, just plug the JVS into the System 246. It might work fine. And I don't know. You know, I only know that these boards work on Time Crisis 3, other than, you know, and Crisis Zone. But yeah, just thought I'd bring that up very quickly. So I shall leave you to look, you know, to get on with your life, and I'll stop rambling now, because it's been 35 minutes of me rambling, and you know, hopefully there's got information in here that's useful. I mean, if you need any, you know, if you've got any questions, give me a message, and I might be able to get back to you and give you an answer on them. You know, I mean, I'm no expert on this system, but I do know my stuff to tell you how to set it up, and how to, you know, what you could do to replace parts, or how you could bypass measures. But I'm no expert in the field, so I'm literally self-taught by all of this. I bought the board and started my revision there. Obviously, if you're going to do stuff like run it outside the cabinet, I would download the schematic. The schematic, although is actually wrong, I think in one or two places. It's nothing really, but I think the schematic I downloaded was off a earlier revision cabinet, which the wire colours are different. All the connections are actually the same. The wire colours are entirely different. Some harnesses are excluded entirely, and the way it's wired in the manual isn't exactly wired in my setup. So, you know, downloading the schematics is always a good start, but take them with a pinch of salt, I say. And I mean, Namco seriously messed up on a couple of theirs, because on what was it? One of the Time Crisis 2 manuals, it tells you to connect the solenoid up to the, you know, the 24 volt input for the solenoid into the light sensor PCB. Now I'll tell you now, and I bet you can imagine, that's not what you're supposed to do. But you know, everyone makes their mistakes, so take them with a pinch of salt. If it doesn't look right, it probably isn't right. You know, as long as you're competent enough to know what voltages go where, and where the data connects to, you know, what data connects to what. Like I say, the manuals give a rough indication of where that is, you should be fine. When I say that Namco messed up with it, it's not like they actually said connect the 24 volt power supply to this part of the PCB. No, it did say connect the I/O board to this part of the PCB. The labelings for the pinout were wrong though, but you know, on the gun connector it's not too hard. You can go, okay, here's the 24 volt power supply, goes into the gun and then goes into the I/O board and then back to the power supply. Now that's clearly a solenoid. Oh wait, this goes from the I/O board straight to the gun, no other connections. That's clearly for the light gun sensor part of it. So yeah, just like I say, take it with a pinch of salt. It might not be entirely accurate. Just use common knowledge and read again, because you cannot you can get it right once, but you can fail in many many different ways, and you know, some ways will cause you catastrophic failures. I mean, thankfully, you can't really mess up so bad with the input voltages, because these regulators take control. I think it's like the 12 volt, you don't have to necessarily worry about too much. You know, clearly, don't ever get the voltages wrong in a power connector, but it's not so much of an issue. But you know, feed 12 volt through 5 volt, bang, bang, you know, chips will just blow up. And if the Spartan chip goes, or the oh, was it the Keycus chip there goes, which is a custom chip, you're screwed. You'll never be able to replace it. If that chip goes, you might be able to. That chip goes, no. So yeah, just, you know, be very careful when when reading through the schematics, because even though they're by the game manufacturer, sometimes they're not exact. You know, they're not correct, or they might be different to what version you have. Anyway, I've now elongated this video to 40 minutes, making this my longest video ever. I am tired, I need a drink, I will leave you be. I hope you found this video informative, I hope you've enjoyed watching, and also, I thank you for watching. Good night everyone.